You're welcome to Spec Deck Constructions, your favorite civil engineering tutorial YouTube channel. Okay, today we have another important topic to discuss. And what's that topic? Standard distance between two RCC columns. Okay, this is a very important topic. You have so many civil engineers asking about this, trying to know what's the distance between two RCC columns. Okay, so when I talk about column, I mean the vertical member in the building. Okay, if you go to the site, people call it pillar. Okay, but the technical name is column. Those vertical members in the building. And when I talk about RCC, okay, what's the word RCC? RCC means R means reinforced, C means cement, and the last C means concrete. Okay, so reinforced. When I talk about reinforced, I mean rod. Okay, when you use rod in cement concrete, okay, you have reinforced it. So why do we reinforce cement concrete? Cement concrete is very strong in compression but weak in tension. Okay, so when we add reinforcement rods to concrete, any concrete structure, it is now called reinforced cement concrete. Okay, so that's where this name originates from. So RCC means reinforced cement concrete. Now back to our topic. We're talking about standard distance between two RCC columns. I'm going to give three instances. Okay, let's say this is our first column, and then these are second column. Okay, and then this is our third column. Now observe something. You're going to see, okay, let's say these are stand on the same level, same level also. Okay, now observe this. You're going to see that each of these columns are having different distances between them. Now we can call this the minimum distance. Okay, minimum standard distance. Okay, we can call this one the normal standard distance, and we can call this maximum distance between two columns. Okay, for the minimum distance, we have the minimum distance between two columns, two RCC columns, is 2.5 meters. 2.5 meters, which can also give you 8.2 feet. Now, coming to this normal standard distance, the normal standard distance between two columns is 5 meters. Normal for a normal residential building, 5 meters, and 5 meters you have 16.4 feet. Okay, now the maximum distance, for the maximum distance between two columns, that is 7.5 meters, and 7.5 meters is going to give you 24 feet. Okay, so these are the standard distances between columns. Okay, so come to think of it, there is one big question. Now, what's that question? What determines your distance between two columns? What is it that determines your distance between two columns? And that is your structural load. So your structural load is the load that is imposed on your column. So that will determine your distance. For example, if you're designing a structure that has high structural load, you should know that the distance between your column should be less. You have to reduce it. Okay, but on the other hand, if you have a high structural load and you still want to increase the distance between your columns, fine, but there's something you have to do. Okay, what is that thing you have to do? That is, you have to increase the depth of your cross section. You have to increase the depth of your cross section. What do I mean by cross section? Follow me carefully. If I have a column here, this is the longitudinal section of the column. Longitudinal section. Okay? Or if I have something like this, this is the longitudinal section of this column. Now, what is the cross section? The cross section is like this, just like you're looking at the column from the top. Okay? When you're looking at the column from the top, this is how you're going to see it. The thing you see is called the cross section of that column. Or even if you section it, the same thing you're going to see. Okay? Now, when I mean depth of cross section, I mean this depth. D. That is the depth of your cross section. And you know how your column looks like if you take a section of your column and you take this cross-sectional view, you're going to have this, okay, and then you're going to have this as well. This is known as your rims, okay, your rims or your tie bars. That's what we call it here, rims or tie bars. And then inside the rim, you have your reinforcement rods, okay. Yeah, so this distance, you know what it's called? It's called your effective cover. Your effective cover. And you have this other distance, which is called your effective depth, small d. Okay, this is effective cover. You can call it C. And this is your total depth, total cross-sectional depth. So we are talking about the total cross-sectional depth in this case. Okay, so what are we saying? We said that if you have a high structural load and you still want to increase the distance of your column, you have to increase the depth, the cross-sectional depth of your column. Okay, per se, if for example, for 7.5 meter, you have a cross-sectional depth of 12 inches. Okay, 12 inches, which is also 1 feet. Okay, if you have a cross-sectional depth of that, okay, and you know that 1 foot is also 300 mm, which is also 0.3 meters. If I want to increase this distance, the distance between my two columns, from 7.5 to 9 meters, I want to increase it from 7.5 to 9 meters. What am I going to do? I'm going to increase the cross-sectional depth of my column. So instead of having 12 inches as my column cross-sectional depth, I can increase it to 14. Okay, I can increase it to 14 inches, which is also 350 mm, which is also 0.35 meter. Right? So if I have a high structural load and I want to increase the depth, the distance between my two RCC columns, what thing I have to do is that I have to increase the cross-sectional depth. And you know what cross-sectional depth is here. So I have to increase the cross-sectional depth in any case. So that is the basic knowledge for today. Very important information to know, to get handy with inside. You know, if you're increasing the distance, then you have to increase the cross-sectional depth. So thank you very much for watching. I hope this video is very helpful for you. You can comment on the section below, and you can subscribe, and you can like our channel for more updates. Thank you very much.